All right, let's get into it. We're about to pull back the curtain on a scientific procedure that is, and I mean this, absolutely fundamental to modern agriculture. But here's the thing, it happens almost completely out of sight. We're talking about the science of bovine embryo recovery, a process that sounds complex, and it is, but it's also like a delicate form of panning for gold. It has completely changed the game for cattle breeding. Now, to really get why this is such a big deal, you have to picture what it was like before. Up until 1976, if you wanted to collect embryos from a prized cow, it was major invasive surgery. We're talking a full-on midline incision, serious risks, and a long, tough recovery for the animal. Then, almost overnight, everything changed. 1976 saw the development of a non-surgical technique. This wasn't just an improvement, it was a revolution. So what did this revolution actually look like? Well, it meant going from a high-stakes surgical operation to a procedure that, while still highly technical, was way, way safer. So let's break down exactly how this non-surgical method works, because the details, they're just fascinating. And the first thing you need to know is that timing is everything. It all hinges on this incredibly specific window, 6 to 8 days after estrus, which is the cow's fertile period. Not day 5, not day 9, it has to be right in that sweet spot. So, why? Why so precise? Well, it's a bit of a Goldilocks situation. If you go too early, say before day 6, your chances of actually recovering anything just plummet. But if you wait too long, you hit a whole new set of problems. Around days 9 or 10, the embryos actually hatch from their protective shells, which makes them super fragile and hard to handle. Wait even longer, past day 13, and they start to stretch out and can get damaged during the collection. So that 6 to 8 day window, it's just perfect. The embryos are mature, they're durable, and they're at the ideal stage for modern stuff like cryopreservation, freezing. So once you've nailed the timing, the next whole phase is just meticulous prep work. You can't rush this stuff. Every single step is carefully designed to set the stage for a successful flush, all while keeping the cow and the embryos safe. And it really comes down to these 3 key steps. First, palpation. The technician manually checks the ovaries to get a sense of how many embryos they might be dealing with. Next up, anesthesia. This is to keep the cow relaxed and prevent her from straining. And finally, and this is a big one, sanitation. Because as you're about to see, contamination is public enemy number 1. What's so interesting here is that disepidural isn't really for pain. It's to stop the cow's muscles from pushing back against the equipment. But it is a super delicate balance. The research points out that a really common mistake is giving too much anesthetic, which can cause the cow to lose control of her hind legs and go down. So it's all about precision. And this right here drives home that point about sanitation. Look at that. The area is scrubbed, cleaned, dried. It's a whole process. And why all the fuss? Because disinfectants are, and this is a direct quote from the source material, extremely toxic to embryos. Any little bit of contamination that gets carried inside on the tools could kill the very thing you're trying to collect. All right, with all the prep work done, we get to the main event, the flush itself. The whole idea here is to gently rinse the uterus with a special fluid, washing out those microscopic embryos so they can be captured. And this is the star of the show. It's called a 2-way Foley catheter. It might look pretty simple, but it is brilliantly designed. One of those little channels is for inflating a tiny balloon that anchors it in place inside the uterus. The other, bigger channel is how the fluid flows in and then back out. Now, a technician has 2 main plays they can run. There's the body flush, which is the faster option. You basically put the catheter in the main body of the uterus and flush the whole thing at once. Then there's the horn flush, which is more targeted. You place the catheter right where the 2 uterine horns split and flush each one separately. So you can already see the trade-off, right? It's speed versus precision. This diagram gives you a great look at that more precise horn flush. See how the catheter is placed right at that fork in the road? The balloon is inflated to seal off one side. Then the fluid goes in, swishes around that one horn to get a really thorough cleaning, and then flows out. After that, the technician has to reposition it and do the exact same thing on the other side. But this is where the skill and the touch of the technician are just so critical. The single most common mistake in this whole procedure, overinflating that little balloon. A tiny bit too much pressure can actually rupture the uterine lining. If that happens, the fluid and all those precious embryos are lost. It's a really high-stakes moment. So once all that fluid has been collected, the next phase kicks off. And this is the part that really is like panning for gold. You've got this big volume of liquid, and hidden somewhere inside are the microscopic treasures you're hoping to find. And you guessed it, there are two main ways to do this. The old school way is the cylinder method. You just pour the fluid into a tall cylinder and wait. For about 25 minutes, the heavier embryos slowly settle to the bottom. It's cheap, but it's slow. The more modern way is the filter method. This is way faster. You run the fluid through a superfine mesh filter that catches the embryos. It's efficient, but the gear costs more, and sometimes the filter can get clogged up. So that brings up the obvious question, right? Which one do you go with? Which one's actually better? And the answer is a classic Business 101 decision. It's not really about which one is better overall. It's about a trade-off, labor versus capital. If you've got more time than money, the cylinder method is great. But if your time is money and you need to process a lot of samples quickly, you invest in the filter system. But no matter how you concentrate the fluid, this is the final hunt. The concentrated liquid is poured into a special gridded dish, and then, under a microscope at 10 to 14 times magnification, a technician slowly scans every single square millimeter, looking for these tiny, perfect spheres. It is incredibly painstaking work. But finding the embryos? That's actually not the end of the line. There's a whole set of crucial follow-up steps to take care of the donor cow and to make sure all this hard work pays off. And the level of detail here is just amazing. First, the embryos that were found get washed at least 3 times. The searching dishes are almost always checked a second time, often by another person, just to be positive nothing was missed. Get this, sometimes they'll even flush the cow again a few hours later, and that can recover about 10% more embryos. And finally, the donor cow is given a hormone to make sure any embryos they might have missed don't result in an unwanted pregnancy. Every base is covered. So all of this brings us to one last big thought. We've just walked through this incredibly technical, mostly invisible scientific process. But what does it all mean? Well, this procedure lets farmers multiply the offspring from their very best animals, which massively speeds up genetic improvement for things like milk production or meat quality. So the real question to leave you with is this. How has this hidden science, this microscopic search for gold, literally shaped the food that ends up on all of our tables?